Quicksort is a divide and conquer algorithm. It picks an element as pivot and partitions the given array around the picked pivot. Consider the following example. Consider first element is pivot element. The element next to pivot is I. Last element of array is j. There are two conditions for quicksort. 1 pivot is greater than element at I. 2 pivot is smaller or equal to element at j. If conditions are true, increment I, and decrement j. Keep checking the conditions. When both conditions do not meet, swap I and j. If conditions are true, increment I, and decrement j. Keep checking the conditions. When both conditions do not meet, swap I and j. Keep checking the conditions. If conditions are true, increment I, and decrement j. Swap I and j. Keep checking the conditions. If conditions are true, increment I. When the positions I and j cross, swap the pivot element with the element at j. This is pass 1. Now the array is divided into two parts. Do the same for each part of array. At the end the array will be sorted. Quicksort's best case occurs when the partitions are as evenly balanced as possible, their sizes either are equal or are within one of each other. And hence the total complexity becomes O(n) ln. Consider the following example. When pivot element is swapped, the array is divided in two equal parts. This is best case scenario of quicksort, then the divided arrays are sorted simultaneously. Worst case, for worst case the partition position happens to be in the edge of array, resulting in another empty array of size n and hence the total complexity becomes O(n)(2). Consider the following example. When pivot element is sorted with j, the pivot gets placed in the last position, which then divides the array into two parts, one with elements and one without, which then increases the comparisons and swaps of the whole array.